Hello, this is Mrs. DB, and today we're going to look at how to write functions, especially how to identify independent and dependent variables, and then also how to write an equation that would be in function notation. This is from Chapter 4, Section 3 of your textbook. Vocabulary is independent and dependent variables, function rule, and function notation. All right, so first of all, we're going to just see if we can figure out what happens to x to get y. Remember that x is the domain, the input. So we are inputting in these numbers, and the output or the range is the y values. So you need to kind of figure out, how did I go from 5 to 1? How did I go from 10 to 2? How did I go from 15 to 3 and 20 to 4? And you have to have the same thing each time. It's the same rule for all of these problems, all of these numbers in this table. So let's see, I could take 5 minus 4 to get 1, but that doesn't work for the next one because 10 minus 4 is 6, not 2. So let's see, how about division? 5 divided by 5 is 1, 10 divided by 5 is 2, 15 divided by 5 is 3, 20 divided by 5 is 4. So these are just like little puzzles that you're trying to figure out. So if every time I take the x value and divide it by 5, that would equal the y value. So my rule, my function rule, that's what we're really writing here, is that each time, well, they're trying different things here, like I did. So they said instead of dividing by 5, they said 1/5. That's the same as the way I wrote it, x divided by 5. So you can either say 1/5 times x or x divided by 5. You could even write it like this, x divided by 5, but we don't usually use the division symbol in algebra. We usually use this if you're typing, which means you're writing it like a fraction, x over 5, x divided by 5. All right, let's try this one. Here's your domain, your input, your x values, and you want to figure out what did they do to each of them to get to the y value. See if you can figure out what you can do to each x value to get the output or the y value. Can you add something? Can you subtract something? Can you multiply something? Can you divide by something? Sometimes it's only one operation, like in the last case where we just had to divide by 5. Sometimes you have to do more than one thing. In this case, it looks like it's going to be multiply by something. Every time you could multiply by 3, I'm going to go back to this, multiply by 3, and you would get the y value. So your rule, you don't have to do all the steps they're doing, is going to be y equals 3 times x. Y equals 3x. So they're going to show this step by step by step. Y equals 3x. Okay, these were functions because every x value had one and only one y value. The input of a function is the independent variable. So your domain, your input, your x values are the independent variables. They get so many names. The output, what you get out of it, is the dependent variable. Here's a way to try to find out which is which. The value of the dependent variable depends on the value of the independent variable. The blank depends on the blank. So this is where dependent goes in this first part. And independent goes here. So if you can rewrite it in this way, the first part is going to be the dependent. All right, let's look at this. A painter must measure a room before deciding how much paint to buy. So we have two different variables here. We have size of room, measure a room, and we have paint, amount of paint. Those are our two variables. Which one depends on which? Does the size of the room depend on how much paint you buy? That doesn't make sense. Or does the amount of paint you buy depend on the size of the room? Yes, the second one. The amount of paint depends on the measurement of a room. Therefore, the dependent is the first part because that depends on the measurement of the room. Okay, let's try this one. the height of a candle decreases d centimeters for every hour it burns. So one of our variables is the height of a candle. And the other one is time, hours that it burns. Now here's a hint. Time can't be changed. Time doesn't depend on anything. So most likely you would say that this is the height of a candle depends on how many hours it's been burning. So the dependent is height of a candle, the independent is time. If you have time, hours, minutes in a problem, that's almost always going to be the independent variable because time doesn't depend on anything. Time just keeps marching along. So if you're in doubt, put time as the independent and see if that makes sense. It usually will. Okay, let's find the independent and dependent variables for this one. A veterinarian must weigh an animal before determining the amount of medication. So we have amount of medication is one variable, weight of an animal is the other. So does the weight of the animal depend on how much medicine you give it? Or does the amount of medicine you give the animal depend on how much it weighs? I hope you'd pick the second one. The amount of medication depends on the weight of the animal. The first part is the dependent, the amount of medication. The independent is the weight of the animal. There's several different ways to describe the variables of a function. The independent variable are the x values, the domain, the input, the x. All of those go together. These are all independent variables. The dependent variables are the y values, the range, the output, and you could write it as f of x or you could write it as y. F of x, this is called function notation. It just means that it's the function of the independent variable of x. Okay, here's a couple problems from your worksheet. It says to identify the independent and dependent variables in each situation. So for each of these, I'm going to rewrite this with the word depends on. A small-sized bottle of water costs $1.99 and a large-sized bottle of water costs $3.49. So we have two different variables that we're talking about here. We're talking about size of the bottle and we're talking about cost. You don't have to worry about the specific, we don't really care. That's not what we're going to worry about. What we're going to worry about is what is the independent, size of bottle or cost. So would you say that the size of the bottle depends on the cost? That means that the cost was picked first. The size of the bottle depends on. Does that make sense? Or does it make more sense to say the cost of your bottle of water depends on the size? Usually, if it is bigger, it'll cost more. So the second one makes more sense, which means that cost is our dependent and size is independent. The first way doesn't make sense. You wouldn't make a bottle and after deciding what the cost was. Okay, number 6. An employee receives 2 vacation days for every month worked. So it doesn't matter about how many vacation days, but vacation days that you get is one of our variables and the other one is months worked. So does the number of vacation days depend on how many months you worked? Or does how many months you work depend on your vacation days? That doesn't make sense. The first one makes sense. The number of vacation days depends on how many months you worked. The more months you work, the more vacation days you'll get. So that means that the first part here, the number of vacation days, that's your dependent. And your independent is how many months you worked. Independent. Okay? Hopefully that makes some sense. Here's another example. Try this one. A company charges $10 per hour, that's one of our variables, cost, to rent a jackhammer. So which one depends on which? Does the cost depend on the time, or does the time depend on the cost? The cost to rent a jackhammer depends on the length of time it is rented. Cost is the dependent, time is the independent. Like I said, time is almost always independent because you can't change it. It just keeps marching along. Okay, one more. Apples cost 99 cents per pound. We've got cost again, and we've got weight. Does the weight depend on the cost, or does the cost depend on the weight? The cost of the apples depends on the number of pounds bought. Dependent cost, independent pounds or weight. Okay, sometimes you have to do both. You have to say what's the independent, what's the dependent, and write a function rule. You can use function notation to do that. It's just instead of y, it's the same thing as writing f of x. They're the same thing. You can do it either way. It's called function notation, but it's just another way of writing y. The dependent variable is a function of the independent variable. That makes sense. Y is a function of x. So you write y equals f of x because f stands for function. So y equals f of x stands for function of x. Okay? So don't freak out when you see f of x. It doesn't mean multiplication or distributive property or anything else. It's just another way of writing y. It's just saying that we have a function of x. All right, let's look at this one. We have to find the independent and dependent variables and then write an equation in function notation. So a math tutor charges $35 per hour. We've got time, hours, and we've got cost again. Pretty much always, most of the time, almost always, it's going to be cost depends on the time. The fee that the math tutor charges depends on the number of hours. So the dependent is the fee or the cost. The independent is the hours. Now we have to write an equation. Now they're going to use h instead of x because h stands for hours. But you could write f of x. You could say that you can always use x. You could say f of x is equal to $35 for every hour that you work. You can either, or you can use h. F of h equals 35h. So these letters here match. If you use h for your variable, then you'd use h in the parentheses for the function of h. But you can always use x. F of x equals 35 times x. This makes sense because $35 per hour. If you work for 1 hour, that's $35. If you work for 2 hours, it's $70. 35 times 2. Okay, here's another one. A fitness center charges $100 initiation fee plus $40 per month. So the independent variable is, well, let's write it this way first. The total cost depends on the number of months plus 100. Plus 100. So the independent variable is the number of months. The dependent is total cost. To write your equation, again, they're using m. You can use x. We know that it's going to be $40 for every month plus the $100 that you have to pay to start out. So again, you can use x every time and say that f of x is equal to 40 times x, x being the number of months, plus the $100. Or maybe you would have wrote $100 first plus 40 times x. This would also be correct. So it's just writing an equation, except instead of y equals, we'll say f of x, function of x. Or if you used m, function of m. Okay, here's what we are going to do for, these are on the assignment. An air conditioning technician charges customers $75 per hour. So we've got a cost and we've got time, hours. So the cost of having this air conditioning technician depends on, depends on time, number of hours. So your dependent is cost, because that came first, and your independent is hours. Independent hours. Now you have to write an equation. So instead of y, we'll use f of x equals, well, it's $75 per hour. If I'm calling that my x, it would be 75 times x. That's it. That's all you have to do for this. Okay, let's look at number 8. An ice rink charges $3.50 for skates and $1.25 per hour. This is going to be a two-part equation. So time and cost again. So again, the cost depends on number of hours that you rent the skates for plus cost of skates. Plus, I'll just write plus 350 because every skate costs 350. Okay, so dependent again is the cost as usual, and independent is the hours. Again, time, independent. Now we're going to write our equation in function notation. Just means use f of x instead of y. All right, so I have to pay $3.50 right away to get the skates. Then, if I skate for 1 hour, it would be $1.25 more. If I skate for 2 hours, it'd be $1.25 times 2. So I'm going to put my x right here. $1.25 times however many hours I skated plus the $3.50 to get the skates. So that's your equation for number 8. Okay, one more example. Stephen buys lettuce that costs $1.69 a pound. Cost and pounds. The cost depends on how many pounds of lettuce. Cost is almost always dependent on something else, right? You pay more for more of it. You pay more for longer of it. And then your expression is going to be f of x equals 1.69 times x, however many pounds you get. Okay, one more example. The amusement park charges $6 parking fee plus $29.99 per person. The total cost depends on the number of persons in the car plus $6. So dependent again is cost, independent this time is number of persons in the car, and your expression, your equation would be f of x equals 6 plus 29.99x, or 29.99 times x plus 6. So you may have seen these maybe in elementary school. I don't know if they're still popular. I saw them in elementary school. They're called function machines. And there's an input and an output. So your input goes in this case, they're putting it in the top, and something happens to it. In this case, it's being multiplied by 5, and then you get output out. So whatever you put in, you multiply it by something, in this case 5, and you get some output out. So if you put x in, multiply it by 5, you get 5x. If you put 2 in, you multiply it by 5, you get 10 out. It's just kind of a way of thinking about functions. Put 6 in, gets multiplied by 5, you get 30 out. So you can evaluate functions with that machine kind of idea. If you put 7 into your machine, here's your machine. What do you get out? You have to multiply it by 3 and add 2. So 3 times 7 is 21 plus 2 is 23. This does not change. Nothing happens to this. It doesn't mean f times 7. It doesn't mean when you're done divide by 7. It just means that the function at 7 is equal to 23. Okay, and the other one, they want us to plug in -4 to our function machine. So you're going to write f of -4. That's just telling you what number you're plugging in. You don't use the left side at all. You don't simplify it at all. You just go ahead, multiply the right side out. You get -12 plus 2 is -10. So if you wanted to finish it up, you'd write f of -4 is equal to -10. This is the answer. Here's another example. Same exact thing, just more practice. They're letting t be 6 and t be -2. So when you put 6 in, you get 4. When you put -2 into your function machine of 1.5 times t minus 5, you get -8. And in this case, it's the same exact thing. They're just giving you different practice problems here. You plug in 600 for r into your function machine of 1/3 r plus 2, and you get 202. When you plug -12 in, you get -2. All right, so this is about it for today's lesson. Just one more thing that I want to look at. This is just another example. These kind of go on and on and on. It's just evaluating. I wanted to go forward to looking at a reasonable domain. So When a function describes a real-world situation, every real number is not always reasonable. For example, if you're talking about the length of an object, it can't be negative. If you're talking about people, you have to use whole numbers. You can't use, decimal numbers for people. If you're talking about time, that can be anything that's positive. If you're talking about buying DVDs, you can't buy a fraction of a DVD. So sometimes you'll be asked to write a reasonable domain and range of the function. And in this case, a reasonable domain would be the integers 0, 1, 2, 3. Because he only has enough money to buy 1, 2, or 3 DVDs. It wouldn't make any sense to have negative numbers. It wouldn't make sense to have a range of numbers like that x was between 3 and 0, because you can't buy decimal parts or fractional parts of a DVD. A range, a reasonable range, would be, well, what do you get if you have these different domain values? If you put 0 into my function, I'd have 15 times 0. So I would get 0. If I put 1 in, I would get 15. If I put 2 in, I would get 30. If I put 3 in, I would get 45. Those are the only values you could have for your range, between 0 and 45, and it's going to be specific numbers because the domain was specific numbers. So it's like a discrete function. All right, so that's it for today's lesson. Try your worksheet. Let me know if you have any questions, and I'll help you out. Thank you very much.